Hi students, welcome to Trigonometric Functions Part 6. Today we discuss the trigonometric functions of sum and difference or compound angles and allied angles. Already you know that. The first one, the measurement of an angles. Second one is the basic concept of trigonometric functions. The third one is trigonometric functions of sum and difference in two angles, sum of two angles or two variables, or you say that it is the compound angles and also allied angles you discuss. These are the very important results in trigonometric functions. You are proving the geometrically only one result, that one is the trigonometric functions of the sum of the two angles cos of x plus 1. The remaining results proving using this concept only. The meaning of compound angle is, suppose x and y are the two angles, the sum or difference of these two angles, sum x plus y or x minus y, these are called the compound angles of two angles. Suppose more than the sum of two or more angles, x plus y plus z, this one is also, or x minus y plus z, or x minus y minus z. These are the three angles. The sum of the angles or difference of the angles are said to be a compound angles. And the same forms the compound of two angles. Here you know that n into pi by 2 plus or minus x. Suppose x is equal to n into pi by 2 and y is equal to x, either x plus y or x minus y. Here n into pi by 2 plus or minus x means, here remember n is equal to 1, pi by 2 plus x, n equal to 1 and minus pi by 2 minus x, pi by 2 plus x or pi by 2 minus x. N is equal to 2, you get pi plus x or pi minus x. N equal to 3, 3 pi by 2 plus x or 3 pi by 2 minus x. N is equal to 4, 2 pi plus x or 2 pi minus x. Already you know the 2 pi plus x is the periodic functions. Therefore, you will discuss in pi by 2 plus x, pi by 2 minus x, pi plus x, pi minus x, 3 pi by 2 plus x, 3 pi by 2 minus x and 2 pi minus x in one complete rotations, in revolutions. These type of angles are called the allied angles. These are in same as sum and difference of the trigonometric functions. Here remember, these are the very important results. The first result here is that, suppose here we can take in the unit circle. Let us consider a unit circle with the center is origin and P is any points on the unit circles. The x coordinate is A and y coordinate is B. The radius of this circle is equal to 1 unit. It is a unit circle. Then you know that the value of A is equal to, suppose this one is AB, arc length is x unit, its center angle is equal to x radian. Here you can say that angles A, OP is equal to x. Arc length is x unit. Then A is equal to cos x and B is equal to sin x. A is equal to cos x and B is equal to sin x. Abscissa means cos x, ordinate means sin x. Already you know that. You can take in the point, the image of a point P with respect to the x-axis. This one is, you said that the horizontal line x-axis and vertical line is y-axis. With respect to horizontal line, to find the image of a point P with respect to x-axis. Image of a point P. It means, suppose you can say that this Q is the image of P with respect to x-axis, or you can say that arc length AQ is also is equal to x unit. This arc length AQ is equal to x unit. Here measure in clockwise directions. Then you say that this one is the minus x angle. Then you say that Q is exactly image of P with respect to x-axis. Then the coordinate of Q is equal to A comma minus B, because this point lies on the fourth quadrant. It's clear? Here angles AOP is equal to x, then angles AOQ is equal to, can say that measure in clockwise directions, its value is equal to minus x radian. Here x radian minus x radians. The arc length x unit x. radian, but in measuring clockwise directions minus x radian. Then q is exactly image of p. Therefore, image of p with respect to x coordinates are same, y coordinate sign is changed. Therefore, here you know that a is equal to always cos x, the center angle, its value is equal to cos of minus x, and minus b is equal to sine of minus x. Here the y coordinate is b. It is clear. B is equal to minus b. Y coordinate means sine of minus x. Here a means x coordinate is a, cos of minus x. Y coordinate is minus b, sine of minus x. Comparing these two, you can say that the results, these are the results. The first result, you know that this a is equal to cos x, this a is equal to cos of minus x. Equating these two, you can say that cos of minus x is equal to minus plus cos x. A is equal to a. A means cos x, a means cos of minus x. This a is equal to cos of minus x is equal to cos x. And the second result, you say that here b is equal to sin x, here minus b is equal to sine of minus x. B means sin x. Therefore, the sine of minus x is equal to minus b. Minus into b. What is b? B means sin x. Therefore, very important results in sum and difference. The first result is cos of minus x is plus cos x, and sine of minus x is equal to minus sine x. With the help of this trigonometric function results, other trigonometric functions. Suppose here you say that this one is the first result, here the first case and the second case. And you say that the third case is tan of minus x. By definition of tan of x means sine x divided by cos x. It means sine of minus x divided by cos of minus x. Its value is equal to minus sine x divided by cos x. Therefore, we can say that minus by plus is minus tan x. Therefore, tan of minus x is equal to minus tan x. Right? Directly minus tan x. The fourth one is cot of minus x. Its value is also cos x divided by sin x. Cot x means cos of minus x divided by sin of minus x. Cos x divided by minus sin x minus cot x. Fifth one is secant of minus x. It is the reciprocal of cos of minus x. Cos of minus x means cos x. 1 by cos x. 1 by cos x means its value is exactly equal to secant x. And the sixth one is the cosecant of minus x. The cosecant of minus x means 1 divided by sine of minus x. 1 by minus plus 1 divided by minus sine x plus by minus is minus 1 by sine x means cosecant x. It is clear. Only here proving the two results. With the help of sine and cos, you are proving the other trigonometric functions. It means cos of minus x is plus cos x. Sine of minus x means minus sine x. Similarly, using these two results, you can say that tan of minus x is minus tan x, cot of minus x is minus cot x, secant of minus x is secant x, and cosecant of minus x is minus cosecant x. Or with the help of different quadrants in the sign in different quadrants in trigonometric functions. This minus x is lies in the fourth quadrant. In fourth quadrant, only cos and secant positive. The remaining trigonometric functions are negative. Because here the first one is cos of minus x is equal to plus cos x, and sine of minus x is equal to minus sine x. Next, very important results here proving in compound angles or the sum of the two angles, using two angles. That one is the second result, very important result. Cos of x plus y is always equal to cos x into cos y minus sin x into sin y. Very important results, usually asked in every years for 6 mark questions. Prove that cos of x plus y is equal to cos x into sin cos y. Cos of x plus y is equal to cos x into cos y minus sin x into sin y geometrically. We are proving geometrically with the help of unit circle. The proof is very simple. It will prove 6 mark questions with the help of unit circle. Let us consider a unit circle. Taking the unit circle with the center is origin. You say that O is the center of a unit circle. Origin is the center of unit circle. Here you can choosing the 4 points. Suppose P1 is the first point. P2 you can take in the second point. P3 is the third point. And P4 is the fourth point. In such a way that, let us assume that P1, P2, P3, P4 are the points on the circle such that arc length P1, P4 is equal to x unit. Arc length P1, P2 is equal to y unit. So I take this one is here. This value is y unit, and P3, P4 in clockwise directions you can take in y unit. Therefore, you say that the angles P4 or P1 O P4 is equal to, this angle is equal to x radian. The angles P1 in a y unit means here P1 P2 is equal to y unit means this angle is equal to y. This angle is y. Therefore, the total angles P4 O P2 is equal to x plus y unit, and in clockwise direction, suppose you can say that this angle is equal to minus y radian. You taking P3 P4 is equal to y unit in clockwise directions. Therefore, this angle P3 O P4 is equal to y unit. Suppose here joining P1 P3. And also P2, P4. Carefully. I said that P1, P2, P3, P4 are the points on a circle such that arc length P1, P4 is equal to x unit, P1, P2 is equal to y unit, and P3, P4 is equal to y unit. Then you say that angle P1 O P4 is equal to x radian, P2 O P4 is equal to x plus y radian, and P3 O P4 is equal to minus y radian, because this one is minus y in clockwise directions. Then suppose here joining P1 P3 and P2 P4, you get the two triangles. This one is the first triangle. O P1 P3 is the first triangle, and the second one is O P2 P4. This one is, and this one is the second triangle. You get the two triangles. Clear? Like this one. I am shading. This one is the one triangle, and this one is the second. Here you get the two triangles. This one is the construction. And remember, the angles P1 O P4 is x unit means the any point on unit circle is always represented by cos x comma sin x. Therefore, coordinate of P1 is cos x comma sin x. Cos x comma sin x. And coordinate of P2 is equal to cos of, here the center angle is x plus y comma sin of x plus y. And coordinate of P3 is equal to, here minus y unit, therefore coordinate of P3 is equal to, this one is cos of minus y comma sin of minus y. and coordinate of P is point on the x-axis, this one is point on the x-axis, coordinate of P, cos of 0, comma sine of 0, cos 0 is 1, sine 0 is 0. These are the coordinates of the point P1, P2, P3 and P4. It means just write, let us assume that OB is center of the unit circle. Consider a circle with the center is origins. OB the center of a unit circle. Let us assume that P1, P2, P3, P4 are 4 points on a unit circle. These 4 points are points on a circle, unit circle, with arc length P1, P4 is equal to x unit, or you can say that angles P1, O, P4 is equal to x radian, angles P2, O, P4 is equal to x plus y, and angles P3O, or you say that P4O, P3 is equal to minus y radian. With the help of arc length, you can take in this. From figure, you say that directly. Here there are two triangles. One is P1 OP3, second one is P2 OP4. These two are the two triangles. Here you know that OP1, OP2, OP3, OP4. These are the radius of the circle is equal to 1 unit. It means OP1 is equal to OP2, and this one is equal to OP3 is equal to OP4. It means the two sides OP1 is equal to OP2, OP3 is equal to OP4. The two sides are equal, and also you know that the angles P1 OP3 is exactly equal to this angle y plus, this one is the angle y plus angle P2 OP3, and this angles P2 OP2 is also, this one is y, in angle is absolute value is y plus P2 OP3. This one is the common angles, y plus the same angle, therefore these two angles are equal. Here you know that two sides and one angles are equal means these two triangles are congruent triangles. It is clear? What is the properties of congruent triangles? Corresponding sides are equal. The properties of congruent triangles means the corresponding sides are equal. Therefore, you can say that from figure, with the help of figure, you can say that the triangles P1OP3 and triangles P2OP4 are congruent triangles. These two triangles are congruent because two sides and one angles are equal. It's clear. It implies corresponding sides are equal. Corresponding sides means this side is equal to this side is equal to this side. Therefore, opposite to angles y plus P2 OP3 is exactly equal to P1 P3 is equal to the corresponding angles means P2 P4. It's clear? It means these two triangles are congruent means corresponding sides are equal. You know that these all are equal to radius 1 unit. Therefore, angle opposite these angles here P1 P3 is equal to P2 P4. These two sides are equal. This congruent triangle is ಅಂದ್ರೆ corresponding sides equal ಆಗಿರುತ್ತೆ. ಹಾಗಾಗಿ ಇದರ opposite ಈ angle equal ಇದೆ. ಇದರ opposite sides ಗೆ equal ಇದೆ. Suppose P1 P3 is equal to P2 P4. Suppose squaring both sides, then it is also equal. Therefore, P1 P3 is square is equal to P2 P4 square. It's clear? What is here P1 and P2, P3, P4? These are the coordinates on the plane. And P1, P3 here A and B are the coordinates on the plane x1, y1, and B is the coordinate x2, y2. Then in a plane, these 2 points are point on a plane. then the distance AB is always denoted by AB. Its value is equal to, using the distance formula, x2 minus x1 whole square plus y2 minus y1 whole square. Using distance formula, you say that x2 minus x1 whole square plus y2 minus y1 whole square. Suppose finding these values, then AB square is equal to root cancel x2 minus x1 whole square plus y2 minus y1 whole square. That one is the distance AB square. Square root is cancelled. Here also P1, P2, P3, P4. These are the coordinate points. Therefore, the distance P1, P3 here, you know that distance P1, P3 is equal to root. Squaring means root is cancelled. P1, P3 means the distance P1, P3 whole square. What is P1? Cos x comma sin x, x1 comma y1. What is P3? Cos of minus y comma sin of minus y, x2 comma y2. Therefore, we can write this one is equal to, you know that using the first result, cos of minus y means cos y and sin of minus y means minus sin y. Therefore, this point cos y comma minus sin y, cos y comma minus sin y. Is clear? This one is x2 minus x1. Therefore, x2 means cos y minus x1 means cos x whole square plus y2 means minus sin y minus y1 means sin x its whole square. Simplify to a minus b whole square, a square cos square y plus b square cos square x minus 2 times AB, 2 times cos x into cos y. Suppose here you know that minus a minus b minus common terms, minus square is plus, a plus b whole square forms. Alright, minus sin y whole square means plus sin square y, minus sin x whole square means plus sin square x, plus 2 times minus sin y into minus plus 2 times sin x into sin y. Simplify using the properties. Here rewrite the same angles cos square y plus sin square y into root. The next one is cos square x plus sin square x, second row. In these two terms, minus 2 is common terms. Cos x, cos y, we are taking minus outside, 2 is outside, therefore write minus sin x into sin y. It implies using the properties or identities, Pythagorean identities, cos square plus sin square is always equal to on the same angle. This one is 1 plus 1 minus 2 times cos x into cos y minus sin x into sin y. Alright, this one is 2 minus 2 times cos x into cos y minus sin x into sin y. This one is the, suppose you say that this one is the first result and this one is say that the second result. And similarly, here find the distance P2, P4, its square. Here P2 means, what is the coordinate of P2? Cos of x plus phi comma sin of x plus phi, and P4 means 1 comma 0. Is clear? Then here write, therefore you better to write what is the, therefore the coordinates of P1, P2, P3, P4. Here write what is coordinate of P1, that is cos x comma sin x. Coordinate of P2, cos of x plus phi comma sin of x plus phi. Coordinate of P3, cos of y comma minus sin y, and coordinate of P4, you know that 1 comma 0 with the help of unit circle. Therefore here what is P2? P2 means cos of x plus phi comma sin of x plus phi, and P4 means 1 comma 0. Here x1 comma y1, x2 comma y2. Here you know that 1 minus cos of x plus y, x1, x2 minus x1 whole square plus 0 minus sine of x plus y whole square. It's clear? Then simplifying this, a minus b whole square forms, its value is 1 plus cos square of x plus y minus 2 times cos of x plus y. 0 minus, it means minus sine of x plus y whole square, minus square is plus sine square of x plus y. Simplify again, 1 plus cos square of x plus y plus sine square of x plus y, 1 group, minus 2 times cos of x plus y. Here you know that this one is 1 plus 1, right, 1 plus 1 minus 2 times cos of x plus y, or you say that 2 minus 2 times cos of x plus y. You say that this one is the third result. We are using these three results from 1, 2 and 3. We are using result 1, result 2 and result 3. From 1 to 3 to write here. Right. From 1, P1, P3 square is equal to P2, P4 square. Using 2, P1, P3 square means its value is equal to, you know that this one is P1, P3 square, its value is 2 minus, it implies 2 minus 2 times cos of x into cos of y minus sin x into sin y is equal to P2, P4 square. Using equations or result 3, here you know that 2 minus 2 times cos of x plus y. Here adding both sides 2, you get 2 to cancel, minus 2 times cos x into cos y minus sin x into sin y is equal to minus 2 times cos of x plus y. Here minus 2 is not equal to 0, cancels these 2, it implies you write cos of x plus y is equal to cos x into cos y minus sin x into sin y. That one is the important result. This is the proof of sum of the two angles in terms of cos. Cos of x plus y, here you know that cos of x plus y is equal to cos x into cos y minus sin x into sin y with the help of unit circle. First from unit circle with the center is origin. Next you can take and choose the 4 points P1, P2, P3, P4 in such a way that the arc length P1, P4 is equal to x unit, P1, P2 is equal to y unit and P3, P4 is equal to y unit in clockwise directions. Therefore angles P1O, P4 is x radian and angles P2O, P4 is equal to x plus y radian and angle P4O, P3 is equal to minus y radian. This one is measured in clockwise. Then the definition of trigonometric functions. Here x coordinate with respect to x, cos x, x coordinate is cos x, y coordinate is sin x. Here x plus y, cos of x plus y, because arc length is x plus 1, x plus 1, cos of x plus y, comma, sin of x plus 1. Arc length is minus y radian. Using clockwise directions, this coordinate is cos of minus y, comma, sin of minus y. But you know that cos minus means plus and sin minus means minus sin. These are therefore the coordinate of P1, cos x, comma, sin x. Coordinate of P2 is cos of x plus y, comma, sin of x plus y. Coordinate of P3 is cos y minus, comma, minus sin y. And coordinate of P4 is cos of 0 degree, comma, sin of 0. Cos 0 means 1, sin 0 means 0. Next from figure you know that these two triangles, the triangles OP1, P3 or P1, OP3 and P2, O, P4 are congruent. You know that this one is, this side is equal to this side is equal to, yes, this side. Here these angles are equal, these two triangles are congruent triangles. Therefore, corresponding sides are proportional. This side is equal to 1 unit, this side is 1 unit. Already you know that. This side is 1 unit, this side is unit. Already you know that. Therefore, you can say that P1, P3 is equal to P2, P4. Squaring, then it is also equals. We are separately find the value of P1, P3 square values using distance formula and simplify. You get the result 2 plus 2 minus 2 times cos x into cos phi minus sin x into sin y. Similarly, here finding P2, P4 square values again using distance formula, you get 2 minus 2 times cos of x plus y. And these two results we are substituting here, you get the values of cos of x plus phi is equal to cos x into cos phi minus sin x into sin y. It is very important results in all the years asked for 6 mark questions. This proof is 5 mark questions. Usually asked cos of x plus phi is equal to cos x into cos phi minus sin x into sin y, geometrical proof. Sometimes here given that, prove that cos of a plus b is equal to cos a into cos b minus sin a into sin b. Here you can choose in this arc length is equal to a and this arc length is b. Therefore, center angle is a radian and this one is b, a plus b radian, and proof is similarly just replacing x is equal to a and y is equal to b. Or in sometimes put that cos of alpha plus beta forms. Here put x is equal to alpha and y is equal to beta, you get cos of alpha plus beta is equal to cos alpha into cos beta minus sin alpha into sin beta. Hence the proof of the second results, compound angles cos of x plus y is equal to cos x cos y minus sin x sin y. It is very important results. With the help of this, to proving the other results, the sum of the or difference of the two angles with the help of this result is very important result. You know that the cos of, I first explain. The third result is, here you know that cos of x minus x plus y is equal to cos x into cos y minus sin x into sin y. It's clear. Using this result, therefore you can say that cos of x minus y is equal to, we place x equal to x but y is equal to minus y. X plus minus y means minus y. It means its value is equal to cos x minus y. It means cos of x minus y. Just replacing y is equal to minus y. Then you get cos of x minus y. Using this result, you know that cos of x plus minus y is equal to cos x into cos of minus y minus sin x into sin minus y. Therefore, this value is equal to cos x. Cos of minus y means cos minus x means plus cos x. Cos of minus y means plus cos y minus sin x into sin of minus y means minus into minus plus sin y. Therefore, you can say that cos of x minus y is equal to cos x into cos y plus sin x into sin y with the help of cos of x minus y. The proof is very simple. Here you remember the third proof is cos of x minus y is equal to cos x into cos y plus sin of x into sin of y. Proof is very simple. You know that cos of x minus y is rewrite cos of x plus minus y. It is clear. Next, explaining cos x plus y, it means its value is cos x into cos of minus y plus minus sin x into sin of minus y. Its value is equal to cos x into cos y, because cos of minus y is plus cos y. minus sine x into sine of minus y means minus sine y. Therefore, we said that cos of x minus y is equal to cos x into cos y. This one is cos y. Cos of minus y means cos y. Minus into minus plus sine x into sine y. This one is the third result. It's clear? Cos of x plus y means cos x into cos y minus sine x into sine y. Cos of x minus y is equal to cos x into cos y plus sine x into sine y. Sine y. This one is the third result. So similarly, they are proving the compound angles sine of x plus y and sine of x minus y. Before we go to the sine x plus y and sine x minus y, here remember the two important results using the lattice angles. The fourth result, using the compound angles, we can prove in the one of the important results in allied angles. Cos of pi by 2 minus x. Cos of pi by 2 minus x. It means here x is replaced by pi by 2, y is replaced by x. Cos of x minus y means cos x into cos y minus sin x plus sin x into sin y. With the help of this result, here simplify this one is cos of pi by 2 minus x. This one is always equal to sin x. Remember, the proof is very simple using previous result. Here we can take in the left hand side. It means cos of pi by 2 minus x is equal to cos x, x means pi by 2 into cos y, y means x plus sin x into sin y, x means pi by 2, sin pi by 2 into sin x. You know the standard angles pi by 2 values? Cos pi by 2 means 0 into cos x as it is, plus sin pi by 2 means 1 into sin x. 0 into cos x is 0 plus 1 into sin x means sin x. 0 plus sin x means its value is sin x. Therefore, you can say that cos of pi by 2 minus x, 90 minus x is equal to cos x. Cos of 90 minus x equal to sin x. It is the fourth result. It's clear? Cos of pi by 2 minus x is always equal to sin x. Or this result can replacing x is replaced by pi by 2 minus x. You get the fifth result. This is the fifth result. Here x is replaced by pi by 2 minus x. Then you get this value is equal to exactly equal to cos x. X is replaced by. Proof is very simple. Here you know that sin x can be written as sin cos of pi by 2 minus x. Here to the value of x is equal to pi by 2 minus x. This one is capital X, you can take. Then here replace by pi by 2 minus x. X is the arbitrary values. This small x equal to pi by 2 minus x. Yes, just replace by. Then here you get this value is equal to that for capital X is equal to here you know that pi by 2 minus small x. It's clear. Therefore you know that sine of x, capital X means pi by 2 minus x is equal to cos of pi by 2 minus x. Cos of pi by 2 minus x. Here x means this one is the capital X is equal to pi by 2 minus small x. Cos of pi by 2 minus capital X means pi by 2 minus x. And simplify this values, remove this bracket. Cos of pi by 2 minus pi by 2 minus into minus plus x. Here plus pi by 2 minus pi by 2 is cancelled, you get cos x. Therefore, the sine of pi by 2 minus x is equal to cos x. This one is the fifth result. The first result sine of cos of minus x is minus cos x or plus cos x. Sine of minus x is minus sin x. Second result, cos of x plus y is equal to cos x into cos y minus sin x into sin y. Third result, cos of x minus y is equal to cos x into cos y plus sin x into sin y. Fourth result, cos of pi by 2 minus x is equal to sin x. Fifth one is sin of pi by 2 minus x is equal to cos x. These are very important results, basic results. And with the help of this, you prove the other results. The sixth one. The sixth result is sin of x plus y is equal to sin of x into cos y plus cos of x into sin y. Proof is also very simple results with the help of previous result. Here you know that the value of sin of pi by 2 minus x means cos x. Sin of pi by 2 minus x is equal to cos x. And also you know that the fourth result, cos of pi by 2 minus x is equal to sin x. With the help of this result, you can say that the sin of x plus y is rewrite cos of pi by 2 minus x. X means x plus y. With the help of fourth result. The fourth result, cos of pi by 2 minus x is sin x. It means sin x can be written as cos of pi by 2 minus x. Here also, here x is replaced by x plus y. Sin of x plus y can be written as cos of pi by 2 minus x plus y. Or here write this one is cos of pi by 2 minus x. Associative properties exist, therefore write a minus b. You can write pi by 2 minus x plus y. Both are same. Next, using the compound angle cos of x plus y, its value is equal to cos of pi by 2 minus x into cos of y, x plus y form, minus sin x, x means pi by 2 minus x into sin of y. Cos x plus y means cos x cos y minus sin x sin y. And also using the results, fourth and fifth, cos of pi by 2 minus x means sin x into cos y minus sin of pi by 2 minus x means cos x into sin y. Therefore, you say that sin of x plus y is equal to sin x into cos y minus cos x into sin y. This one is the sixth result. Very important results. Proof is very simple using the previous. Not using the numerical proof is not necessary. Using the previous result, you prove that cos sin of x plus y is equal to sin x into cos y minus cos x into sin y. And with the help of this result or using the previous result, the seventh result, you can prove that sin of x minus y is equal to sin x into cos y minus cos x into sin y. Here also the proof is very simple using the previous results. Here the proof is the same method using, here you know that sin of x minus y can be written as sin of x, or using this result, x is replaced by, you can write sin of x plus minus y. It is better. Sin x plus y is the standard result. You apply directly. This one is equal to sin x into cos of minus y plus cos x into sin of minus y. This one is sin x into cos of minus y means plus cos y plus cos x into sin of minus y means minus sin y. Sin x into cos y plus into minus minus cos x into sin y. Therefore, the sin of x minus y is equal to sin x into cos y minus cos x into sin y. Sine of x plus y, sine x into cos y plus cos x into sine y. Sine of x minus y, sine x into cos y minus cos x into sine y. These are the trigonometric ratios of x plus y and x minus y in terms of sine and cos. Using these two results, you do the tan and cot is also important results, proving the tan and cot functions. Here you know that already once recall, sine of x plus y means sine x into cos y plus cos x into sine y. The similarly sine of x minus y means sine x cos y minus cos x sine y, and similarly cos of x plus y is equal to, already know that, cos x into cos y plus minus sine x into sine y. Therefore cos of x minus y is equal to cos x into cos y plus sine x into sine y. ಇಲ್ಲಿ sin change plus ಇದೆ, plus ಬರುತ್ತೆ, minus ಇದ್ದಾಗ minus in sin of x plus y and sin of x minus y. Plus ಇದ್ದಾಗ minus, minus ಇದ್ದಾಗ plus ಹೋಗುತ್ತೆ. In case of cos of x plus y and cos of x minus y. It's clear? With the help of this, you prove in the 8th result the tan of x plus y and tan of x minus y. Remember this result, tan of x plus y is equal to tan of x plus tan of y divided by 1 minus tan of x into tan y. Tan of x plus y is equal to tan of x plus tan of y divided by 1 minus tan of x into tan of y. Proving this result, and similarly tan of x minus y is equal to tan x minus tan y divided by 1 plus tan x, 1 plus tan x into tan y. The proofs are very simple. Using the previous result, here we can take in tan of x plus y, just using by definition of tan. What is the value of tan x? Sin x divided by cos x. Here x is replaced by x plus y. Sin of x plus y divided by cos of x plus y. Next, using the compound angles, the sin x plus y, you know that sin of x into cos of y plus cos of x into sin y will divided by cos of x plus y means cos of x into cos of y minus sin of x into sin of y. Suppose dividing both numerator and denominator by cos x into cos y, both numerator and denominator, divided by cos x into cos, both numerator and denominators. It means dividing in numerator cos x into cos y, sin x cos y plus cos x sin y, here divided by cos x cos y. In denominator is also cos x cos y minus sin x sin y divided by cos x into cos y. It's clear? Dividing both numerator and denominator by cos x into cos y. Then simplify this result. Therefore tan of x plus y is equal to, simplify right hand side, a plus b, you know that a plus b divided by c can be expanding, a by c plus b divided by c. It is clear? Here also you expanding this, sin x cos y divided by cos x cos y cancel, to get the remaining term sin x divided by cos x, the first term, plus expanding the second terms, cos x sin y divided by cos x cos y, cos x cos x cancel, sin y divided by cos y, sin of y divided by cos y in numerators. In denominators, cos x cos y divided by cos x cos y, both are cancelled, 1 minus sin x cos y, sin y cos y. You write this value sin x cos y, term is not cancelled, you write as it is, but grouping sin y divided by cos y. You know that this value sin by cos means tan of x plus sin y divided by cos y means tan of y divided by 1 minus sin by cos means tan of x, sin y by cos y means tan of y. Therefore, you can say that tan of x plus y is equal to tan of x plus tan of y divided by 1 minus tan x into tan y. Similarly, proving the third result, this one is homework, the same methods. Tan of x minus y is equal to tan x minus tan y divided by 1 plus tan of x into tan. The same proof is the similar way. You know that tan means sin by cos. Sin x minus y means here x, here sin x cos y minus cos x sin y. Cos of x minus y means cos x cos y plus sin x. Dividing both numerator and denominator by cos x into cos y cancels again. Sin x cos y minus sin y cos y divided by 1 plus sin x cos x into sin y cos y. You get the result tan x minus tan y divided by 1 plus tan x into tan y. The other result proving in next class. Thank you.